Have you ever noticed that some power cables are twisted together instead of running straight? You can see this on utility poles and even inside electrical cables. The pattern may look simple, but those twists help solve several problems that are easy to overlook. So why did engineers begin twisting power cables together, and why has this design become so widely used around the world? Today, we will unravel the surprising story behind twisted power cables and discover why a simple twist changed the way electricity is delivered right here on History of Simple Things. The idea of twisting wires dates back to the early days of electrical communication in the 19th century. As telegraph lines spread across countries, engineers discovered that long, straight wires were vulnerable to interference from nearby electrical currents, lightning, and other telegraph lines. These disturbances often garbled messages. When telephones arrived, voice signals required much cleaner transmission than telegraph clicks. One of the biggest breakthroughs came in the 1880s when engineers realized that twisting two conductors around each other greatly reduced electrical interference. The twisting caused both wires to experience nearly the same amount of outside electrical noise along the cable's length. Because both wires picked up nearly the same interference, the receiving equipment could cancel most of it out. It was a simple but effective solution requiring only a carefully controlled twist. This principle became especially important for telephone networks. As cities filled with more electrical equipment, streetcars, factories, and power lines, interference became a growing problem. Twisted pair wiring helped keep conversations much clearer. Even today, Ethernet cables and many older telephone lines still rely on the same principle. Despite modern advances in electronics, this simple twist remains one of the most effective engineering solutions ever developed. But what about the power cables we see outside? Their twisting often serves additional purposes beyond reducing electrical noise. In many low-voltage distribution systems, several insulated conductors are twisted together to form what's known as an aerial bundled cable. Before these became common, many neighborhoods used separate bare wires on crossarms. While effective, they were vulnerable to tree branches, strong winds, accidental contact, and wildlife. By twisting insulated cables into a single bundle, engineers created a system that is both safer and more durable. The cables help support one another mechanically, distributing tension more evenly along the line. During strong winds, bundled cables sway together instead of independently, reducing the risk of wires striking each other or becoming tangled. Their compact design also makes installation easier in crowded urban areas where space is limited. The twisting itself also improves mechanical strength. Imagine twisting several strands of rope together. The finished rope becomes stronger and more flexible than a collection of separate strands. Power cables benefit from a similar effect. Twisting helps the conductors share mechanical loads, making the cable more resistant to stretching and vibration over years of use. This is especially valuable in areas with frequent storms or changing temperatures, where cables constantly expand, contract, and move. There's another invisible advantage involving electricity itself. Whenever current flows through a conductor, it creates a magnetic field around the wire. If conductors carrying current are arranged carefully, such as by twisting them together, their magnetic fields interact in ways that reduce the amount of electromagnetic radiation escaping from the cable. This not only helps reduce interference with nearby equipment, but also improves the efficiency of the electrical system in certain applications. You might wonder why every power line isn't twisted if the design is so useful. The answer depends on the type of electrical system. High-voltage transmission lines, the massive towers carrying electricity across long distances, usually keep their conductors separated by large distances. At these extremely high voltages, engineers focus on preventing electrical arcing, managing heat, and reducing power loss. Engineers have continued refining twisted cable designs over the decades, using better insulation, stronger materials, and more precise manufacturing techniques. Yet the underlying principle has barely changed because it works so well. Sometimes the best engineering solutions aren't the most complicated. They're the ones that use simple physics in clever ways. Perhaps that's what makes twisted power cables so fascinating. They don't stand out like towering power stations or massive transmission towers. Most people pass them every day without giving them a second thought. Yet each twist represents generations of engineers learning how electricity behaves and finding practical ways to make our electrical systems safer, quieter, stronger, and more reliable. So the next time you notice a bundle of twisted cables stretching between utility poles or hidden inside a wall, you'll know you're looking at far more than neatly arranged wires. You're seeing a design that began with the earliest telegraph systems, helped make clear telephone conversations possible, strengthened modern power distribution, and continues to carry both electricity and information through our everyday lives. Sometimes one simple twist is all it takes to solve problems that once seemed impossible.
Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.